8.2 Example 9. In Example 9, we're going to look at what happens when a limit approaches 0 to the 0 power. So in Example 9, we're going to look at the limit as x approaches 0 from the right of x to the x power. Now by doing a direct substitution, you get 0 to the 0 power. Again, this doesn't tell us much because the 0 to the 0 power means 0 divided by 0, which we can't do. So what we're going to do here is we're going to let f of x equal x to the x power. This means that we're going to be able to take the ln of both sides. So we can take ln of f of x, and this is going to equal ln of x to the x power. So this is going to equal x times ln to the x, which I can write as ln divided by 1 over x. What I can do from here now is take the limit, and so I get that the limit as x approaches 0 from the right of ln of x divided by 1 over x is going to equal negative infinity over infinity. Because I get this, now I can use L'Hopital's rule. And by using L'Hopital's rule, I get that this is the limit as x approaches 0 from the right of 1 over x divided by negative 1 over x squared. So this is equal to the limit as x approaches 0 from the right of 1 over x times negative x squared over 1. This is equal to the limit as x approaches 0 from the right of negative x, which is just equal to 0. However, we're not done. Because we took ln of both sides, now we need to raise it by e. So we're going to get, therefore, the limit as x approaches 0 from the right of x to the x is equal to the limit as x approaches 0 to the right of f of x is equal to the limit as x approaches 0 from the right of e to the ln of f of x, which is equal to e to the power as the limit approaches 0 of ln of f of x, which we just proved to be e to the 0. So this is equal to 1. So our final answer is simply just 1. All right, on your own right now, I want you to try to determine the limit as x approaches 1 of x squared minus 2x plus 1 to the power of x minus 1. By applying a direct substitution, we get that this is 1 squared minus 2 times 1 plus 1 to the 1 minus 1, which gives me 0 to the 0th power. So this means I need to do a little manipulation before I can use L'Hopital's rule. So we're going to let f of x equal x squared minus 2x plus 1 to the x minus 1 power. We're going to take the ln of both sides. So we get ln of f of x is equal to x minus 1 times ln of x squared minus 2x plus 1. And if we want to rewrite this to have a fraction, this is ln of x squared minus 2x plus 1 all divided by 1 over x minus 1. Basically what we're doing is we're taking this x minus 1 and we're flipping it to put it in the denominator. So now we can take the limit as x approaches 1 of ln of x squared minus 2x plus 1 divided by 1 over x minus 1. And this is going to give me ln of 0 divided by 1 over 0, which gives me negative infinity over infinity. Now that I have this, I can apply L'Hopital's rule. So this equals using L'Hopital's. Now be careful. The derivative of ln is 1 over the inside, so 1 over x squared minus 2x plus 1 times the derivative of the inside, so 2x minus 2, and the derivative of the bottom piece is going to be 1 over x minus 1 squared with a negative. And the derivative of the inside is just 1. So this is equal to the limit as x approaches 1 of 2x minus 2 divided by x squared minus 2x plus 1, all divided by negative 1 over x minus 1 squared. And this is equal to the limit as x approaches 1 of 2x minus 2 divided by x squared minus 2x plus 1 times x minus 1 squared over 1, and put a negative in front. So this is equal to the limit as x approaches 1 of negative 2x minus 2 divided by x minus 1 squared times x minus 1 squared. This piece right here comes from factoring the denominator in the previous step. So these are going to cancel, and I get that this is equal to the limit as x approaches 1 of negative 2x minus 2. And if I plug in 1, I'm going to get 0. And so we're almost done. Since we took the ln in the beginning, we then need to raise it to the e. So you get the answer is e to the 0. So the limit as x approaches 1 of x squared minus 2x plus 1 to the x minus 1 is equal to e to the 0, which is 1.